So what happens if we're given A but not B? When we're given the initial value in an exponential formula, they're telling us what A is. In the last couple problems, they gave us the information we needed to find B, but sometimes we're given a data point instead of the exact value of B from the start. In that case, we can use the data point and calculate B. Before we start this, let's just point out that when we're solving types of problems like this, we end up with equations of the form b to the n equals c, where in this case we could have b as our variable, we could have b cubed equals 5, for example. N and c are just numbers, and we're trying to find the value of b. So how do we do that? Well, we can take our equation b to the n equals c, and in order to undo raising to the power of n, we can look at the nth root of both sides, which is the same thing as raising this to the power of 1 over n. Anything we do to the left-hand side, we have to do to the right-hand side. Notice that this notation is equivalent to taking the nth root. And in doing so, your exponents cancel. The nth root undoes the raising to the power of n, and so we're left with b is the nth root of c, or equivalently, c to the 1 over n. Let's give this a shot. Same setup as before. A pack of 65 wolves is released into Yellowstone National Park, and after 3 years, the population has increased exponentially to 85. We know this is going to look like f of x equals a times b to the x, or actually this will be 65 times b to the x, since we already know our initial value. So what we need to do is use the extra information given in the problem to write another equation. Specifically, we know that the population after 3 years, f of 3, is going to be 65 times b to the 3, and then after 3 years, this population will be 85. If we ignore the left-hand side, just for now, we can simplify this equation. Specifically, if we divide both sides by 65, then the 65s cancel, and we get b to the 3 equals 85 over 65, or if we were to write that as a decimal, that would be approximately 1.308 if we're rounding. If we want to find the exact value of b, then we need to undo this to the power of 3 by looking at the cube root of it. So that's raising to the power of 1/3, or looking at the cube root. And anything we do on the left, we have to do the same thing on the right. So we could say b is exactly the cube root of 85 over 65. And if we type that into our calculator, we get that this is approximately equal to 1.094, we'll say. Now it's important here that we use this exact arithmetic, or at the very least keep many more decimal places than I wrote here. Otherwise, when we go on to use this value of b in later calculations, our answer is going to be off. So in general, we want to keep this exact, or we want to use all the decimal places that our calculator gives us, not just 2 or 3. Let's try one more. We'll buy a car for $24,000. After 4 years, we learn that the car is worth $11,000. And again, we're going to assume that this is decreasing exponentially and not linearly, and therefore the cost is going to be in the form a times b to the x, or actually 24,000 times b to the x. Once again, we're going to use the information in the problem. After 4 years, it's worth $11,000. So we could write c of 4 is 24,000 times b to the 4. And this equals $11,000. We're going to go ahead and simplify the same way as before, trying to get b by itself. So that after simplification, we're left with b to the 4 equals 11,000 over 24,000, or we could just write this as 11 over 24 if we wanted. From here, we're again going to take the 4th root of both sides. That's the same thing as raising this to the power of 1 over 4. And the 4th root of b to the 4, those cancel, and we're left with just b is the 4th root of 11 over 24, which is approximately equal to 0.823. Again, leaving this as 11 over 24 to the 1/4, or to the 1/4, or the 4th root of 11 over 24, those are our preferred options. So, in class, we are going to work in pairs to complete problems similar to those in this video. We're going to learn how to create exponential functions when we aren't given a or b, and we have to determine both of them. And at the end of class, we will do a muddiest point, where you write down the thing you're struggling the most with. See you then.